So with that, I'm going to turn it over to Brian Zappler to talk to you more about the projections.
Thank you. This is going to be a math lesson, nothing more, nothing less. So you'll bear with me, but it really is scintillating to us mathematicians, I guess. So in projecting student enrollment, I like to start off by saying that it is both a science and an art. The science piece is fairly straightforward. We have data, we have mathematical equations, we plug the data into the mathematical equations, and we get enrollment projections for a number of years. But we also, the art form comes in that computers can't really accommodate what we call unanticipated or anticipated things. We have in the school system a anticipated futures database that we keep because we learn stuff by talking to people about things that the computer could not take into account into some of its projections. So sometimes when we get the numbers, we may modify them just a little bit, not huge, but just a little bit because of things that we know about. For example, if students are registering in Glastonbury Public Schools for the first time, we ask, do you have any younger brothers and sisters who are pre or before kindergarten age? And we take note of that, and we note what year they're going to be coming into kindergarten. For some residents, their students may be going through a pre-kindergarten evaluation process, but they may not be eligible for services. But we take note, okay, we could expect them to come into kindergarten in the future years. We have staff on a tuition basis who don't live in town, and their students may be coming here, and we also make note of are there any younger siblings. So we take a lot of these things into account when we take a look at the numbers. And the combination of art and science, if you will, in our projection has been pretty successful over the years. As Matt has said, NESDEC affirmed that the system that we're using is a valid one, and we've been accurate to within 0.5% every year going back for a number of years. So we think that the way that we're doing projections as validated by NESDEC and our track record is pretty good. So some of the assumptions and terminology that we need to start off with, because this will be reoccurring throughout my presentation on how we calculate projection. Obviously, students enroll in kindergarten for the most part 5 years after they're born. Students born in 2010, we would expect that they would come into kindergarten in 2015. We use a cohort survival rate, and this is something that will be repeated throughout this presentation because it's very important, especially in our kindergarten enrollment projections. And that is, what is the percent of change from kindergarten enrollment to the births 5 years ago? That's a cohort. And it's a mathematical formula right there where we take the current year kindergarten enrollment, we subtract the birth number from 5 years prior, and then we divide that by the births of 5 years prior. So it's a straight mathematical formula that we use. The kindergarten projections, this is where we use and apply the cohort survival method to the birth rate 5 years prior. So in this case, the formula is 1 plus the cohort survival rate times the births from 5 years ago. Now that seems to be, can be quite complicated. So what I'm going to try to do is illustrate this through an example. Now, this example right here uses fictitious numbers. I chose to use some rounded numbers to hopefully make it a little bit, the explanation a little simpler. And you'll see that it's a one-year trend, which we never use. But again, for the sake of simplicity, I chose to just round numbers in a one-year trend. So the methodology, the first thing that we would need to do if we are going to project, the goal here is to project the enrollment for the 2016 kindergartners, is to do the cohort survival rate. In doing that, we take a look at our current enrollment, the 2015 kindergarten enrollment. We subtract out the 2010 births, that's that cohort that were born in 2010, and we divide that by the 2010 births. So if you do out the math, you can see that we take the enrollment, 150, subtract out the birth number from 5 years prior, and divide that by the birth years from 5 years prior, and we get a rate of 0.50. So that's our cohort survival rate. Now we use that rate in order to project kindergartners for 2016. And we'll remember that the kindergartners in 2016 were born in 2011, 5 years prior. The formula being 1 plus the cohort survival rate times their 2011 births. You can see the math play out there, and that we would see a projection in this scenario of 143 kindergartners coming into our schools in 2016. Again, these numbers are more for simplicity, an example, and certainly a one-year trend is something that we don't do. It does tend to get a little bit more complicated when we start going out and saying we want to take a look at a 2-year trend, a 3-year trend, a 4-year trend, but the basic methodology is the same. So let's move to our 2-year trend. In considering enrollment projections for kindergarten, again, in 2016, we have to look at 2 cohorts, 2 school years worth of information. Cohort A, born in 2009, enrolled in kindergarten in 2014. Cohort B, born in 2010 and enrolling in kindergarten in 2015. We're going to project 2016 kindergarten enrollment, and that cohort we know is born in 2011. The first step that we would need to do is we need to take the difference between the kindergarten enrollment and the births for each cohort and sum them, add them together. Take the kindergarten, subtract out the births for each of the 2 cohorts, and add them together. If you take a look at cohort A, it's the 160 minus 120, which gives me 40. Cohort B is 150 minus 100, which gives me 50. I total those 2 cohorts up for a total of 90. That's an important number. We will carry that forward. Step 2 is I need to take a look at the total births from the 2 cohorts, cohort A and cohort B, in the school year 2000 or in year 2009 and 2010. Simply adding those together, the number of births in those 2 years is 220. Again, an important number that we'll need to carry forward as we start figuring out our cohort survival rate. And again, what I've shown there is just those important numbers that I've carried forward. So again, the equation is the same. We take the K enrollments minus the births over the births, and we know that that's 90 over 220. So for this particular example, we would get a cohort survival rate of 0.41. Step 4 would be to project the 2016 kindergarten enrollment using our survival rate, 1 plus the cohort survival rate times my 2011 births. You can see the math play out there, and we would project 2016 kindergarten enrollment at 134 in this scenario. So that's how we go through and project the kindergarten enrollment for the following school year. That's just that 1 year. Now, we also know that if you recognize this chart, this is from the budget book. This is our enrollment report that we run every year and present to the Board of Education in November. And what we're going to be doing here is we have to project out students that have been born. We know that these are real student births or real children births that have happened. And those numbers or those projections are highlighted in the yellow part of this chart. So it's going to be the same equation. We find that cohort survival rate, and then we apply it to the births 5 years prior. For an example, if students who were born in school year 2017-2018, the formula would be 1 plus the cohort survival rate times the birth from 2012, 5 years before their enrollment in kindergarten, and so on and so on. I won't go through every single one of them. So that's pretty straightforward. But now we have to talk about the students that have not yet been born yet. And these are represented in blue. And this gets a little bit trickier because we don't have an established cohort yet. So we do a little bit different methodology for that. In this instance, what we do is we take a look at what has the birth rate been. We take a look at the birth rate over the past 2 years, over the past 3 years, over the past 4 years. And that's very important because that will come into our equation for projecting those blue students, yet to be born students. We take the previous year kindergarten projections that we've already calculated, and we multiply that times 1 plus the annual birth rate. So if you take a look at kindergarten for 1920, it shows a figure of 311. We would take that, if we want to project 2021, we take the year before, that 311, times 1.0304 in this case. And you can see that that would show a slight uptick or increase of 320 students. And we do that same methodology for 21, 22, 22, 23, and so on and so on. So that's what we have to do for kindergarten. But we still have 11 more grades to go. So I won't go through every single grade because it is pretty much the same process that we do. And when we project, we feel that this gets a little bit easier because we have hard numbers. We have enrollment numbers. So we know what's going on in those grades, and we have historical information from how many kids survive, if you will, when they move from one grade to the next. So the equation here is you're taking the previous year enrollment, or a projection, depending upon what year it is, and you multiply that times 1 plus the cohort survival rate from one grade to the next. So we figured we would calculate the cohort survival rate for first graders going into second grade. Then we'd have to figure out a cohort survival rate for students going into second to third and third to fourth, a whole bunch of them. And I think that where we had some accuracy is that there are some school districts who will just take a look at the elementary school as a whole and say, what's the average survival rate? And they'll apply it across the board instead of going into each grade level and projecting that cohort survival rate 12 times. So in this example, if we take a look at a 2-year trend, it's kind of sticking what we've been working with, and looking to project enrollment in grade 3. And you can see that I have numbers there in red and in green, which indicate the 2 cohorts that we're going to focus on. So the first step is we need to calculate the change in enrollment from students going in grade 2 to grade 3 over 2 years. Year 1 would be red, indicated by red. Year 2 would be indicated by the green. So if I play out the mathematical formula there, I say, okay, how many in 2015, take my grade 3 and subtract it from 2014 grade 2. They were in grade 2 in 2014. I look at the numbers and I say, okay, typically in that situation, there would be 20 more students that we would see going from grade 2 to grade 3. In doing the same thing for year 2, well, except I have to go back a little bit, where I take my grade 3 students in 2014, subtract out when they were second graders in 2013, do the math, and you can see that when I add those 2 years together, I get a figure of 27, which is, we need to carry that. That's an important number. We're going to need to carry that forward. Step 2 is take a look at the grade level enrollment over 2 years from the previous grade. In this example, we say, okay, what was the total grades population for 2 years in grade 2? I add that up for 802. Calculate our survival rate, where we take the change in enrollment from grade 2 to grade 3, which we indicated was 27. Divide that by the total grade enrollment from the previous grade level, which was 802, to get a cohort survival rate of 0.0337, and then make our projection. Taking previous year's grade 2, applying my cohort survival rate, so we would anticipate in 2016 a grade level of 408 students in grade 3, population of 408 in grade 3. I'm going to hand the presentation back over to Matt right now, and certainly I will stay around in case there are any questions at the end of the presentation.